Okay, now that we've talked about the containers in 0, 1, 2, and 3 dimensions, now it's time to start looking for patterns to sort of begin to understand what a 4-dimensional box must look like. So we have 0-dimensional, 1-dimensional, 2-dimensional, 3-dimensional, and hopefully 4-dimensional. Let's start with the solid boxes. That's a solid 0-dimensional box. That is a solid 1-dimensional line segment. That is a solid 2-dimensional square. That, if you take my word for it, is a solid 3-dimensional box. Who knows what a 4-dimensional solid box looks like? Next, let's look at the empty boxes. An empty 0-dimensional box is a place for a dot. An empty 1-dimensional box is 2 single dots. An empty 2-dimensional box is an empty square. An empty 3-dimensional box is an empty box. And who knows what a 4-dimensional box is? Excellent. Now let's look at how many vertices each have. Well, okay, let's go back to the solid boxes. There's one dot there. So if there's one dot, it's one dot. It doesn't even need coordinates because you don't need coordinates in 0 dimensions, but we will say that there is one vertex for a solid 0-dimensional box. Well, for either one. Well, see, there's nothing there, but whatever. But these get easier. A 1-dimensional box has 2 vertices, the left point, endpoint, the right endpoint. A 2-dimensional box has 1, 2, 3, 4 corners, 4 vertices. A 3-dimensional box has 1, 2, 3, 4 on the bottom, and 1, 2, 3, 4 on top for a total of 8. And now we think, what is the pattern here? There is 1, then 2, then 4, then 8. Hopefully you notice that you're doubling each time. 1 times 2 is 2, 2 times 2 is 4, 4 times 2 is 8. The next one is 16. So that tells us that a 4-dimensional box ought to have 16 vertices. Excellent. Now let's look at the number of sides. Doesn't make as much sense to talk about the sides of an empty, we're talking specifically of an empty 0-dimensional box. It has no sides. But a 1-dimensional box, we're going to say yes, it has 2 sides. The one endpoint and the other endpoint. We're talking about the empty boxes now. 2 sides. A square has 1, 2, 3, 4 sides. A cube has 6 sides. There's the top and the bottom, the 2 sides, and the front and the back for a total of 6 sides. So what's the pattern here? 0, 2, 4, 6. We are not doubling at all because there's nothing you can multiply 0 by to get 2. If we multiply by 2, we get 4, but if we multiply again, we'd get 8. So it's not doubling, it's adding. Add 2, add 2, add 2. So we would assume 8. 8 sides on a 4-dimensional cube, hollow cube. And finally, what are those sides? The shape of the sides. Well, a 2-dimensional, there's no sides on a 0-dimensional box, so we'll say none. A 1-dimensional box, the 2 sides that it has are solid 0-dimensional boxes. These 2 endpoints are solid 2-dimensional boxes. Well, what are the 4 sides of a square? 1, 2, 3, 4. They are solid line segments. They are solid 1-dimensional boxes. What about the sides of a 3-dimensional cube, a hollow cube? Those 6 things that it has are all solid squares. They are solid 2-dimensional boxes. So what's the pattern here? Nothing, no sides, 2 solid 0-dimensional boxes, 4 solid 1-dimensional boxes, 6 solid 2-dimensional boxes. We can only assume that a 4-dimensional cube consists of 8 solid 0, 1, 2, 3-dimensional boxes. So somehow if you take 8 cubes and you arrange them in the right fashion, you can enclose a 4-dimensional space, which we will see in the next video.